Hey everyone, welcome back. In this video, we are covering the intermediate value theorem, also known as the IVT. So this theorem states if f of x is continuous on the closed interval a to b, and n is any number between f of a and f of b, then there exists a number c in a, b, such that f of c equals n. So this sounds like a bunch of gibberish, but let's go ahead and break this down with a quick little picture. So first things first, you have to note this. This is the most important part that I've highlighted here. The function must be continuous in order to apply the intermediate value theorem. And so now let's go through what this may mean. So let's call this A and let's call this B. And let's just say our function f of A output value is here. And let's say for B, f of B, let's say our function output value is up here. So this can be used to find zeros of a function. So this is kind of the example I'm drawing here. So let's just say f of a is, I don't know, -5, and let's say f of b is +5. Well, in order to get from -5 to +5, if our function is continuous, I might go up and down, right? But eventually I have to cross through 0 in order to get from -5 to +5. So that is literally the only thing that the IVT is telling us, is that it has to pass through every output value between wherever we start, which in this case was -5, and wherever we end, which in this case is 5, right? So we have to cross through every value to get there. Again, because the function is continuous, right? An easy way to kind of draw a continuous function is to just not lift your pencil up, right? I can go up, I can go down, but eventually I have to go through all of these values. So now let's go ahead and move on, and let's look at a couple of practice problems to really bring this home. So first question states, let f be a function such that f of 5 is less than 6 is less than f of 7. Which of the following statements provides sufficient additional information to conclude that there is a value x equals c in the closed interval 5 to 7 such that f of c equals 6? So immediately I'm thinking of IVT here, and I have to think of the requirements, which again we already talked about. Our function must be continuous. So the correct answer choice here would be C. Okay, moving on to the second question. This one states the table above gives values of a function g at selected values of x. Which of the following statements, if true, would be sufficient to conclude that there exists a number c in the interval 0 to 7 such that g of c equals 50? Okay, so again, we have this table of values up here. We are talking about the interval from 0 to 7, which is given there. And we want to know how we could conclude that there is an output value of 50. So again, immediately we want to be thinking of the IVT here and the requirements, right? And the requirement that we have to know is that G is continuous, right? So that is how we would guarantee that going even just from 3 to 7, right? We would have to cross through 50 if the function is continuous. So the correct answer choice here would be answer choice B. Okay, moving on to the last question. This question states, let f be the function given by f of x equals x plus tangent of x over 5 minus 10. The intermediate value theorem applied to f on the closed interval 12, comma 15 guarantees a solution in 12, comma 15 to which of the following equations? So for this one, in my opinion, it is easiest if you graph this. You could, of course, do this algebraically by just plugging in 12 for x and then 15 for x, but I've gone ahead and pasted a picture of the graph over here to the right, and we can see our output values here. So this point has an output value of approximately 1.08. This one has an output value of approximately 4.86. And the most important thing, of course, is that we note that this is continuous. This function is continuous on that closed interval. So we can apply the IVT, which is kind of already implied in the problem, but just to kind of hammer in that idea that the function must be continuous, it's always good to note that. So now we need to find an answer choice where the function is between one of these values. So the only answer choice would be answer choice C, y equals 4. So if I were to draw this on the graph, right, it would be somewhere something like this, and this would be the solution that they're talking about where those two lines intersected. All right, thanks so much for watching, and I will see you in the next video.